Hi everyone, this is Team 6, and we are present our project, which is the Doodle Jump based on the DE10 Nano board. And to give in the overview, we integrate the Doodle Jump game with the DE10 Nano board and with the others cloud services. And the project capitalized the G sensors on the DE10 Nano board to offer an immersive gaming experience. And with the cloud services, the player scores are securely logged and which forest contains global communities. And our innovation adaptations involving like several keys in components, which is the first is the gaming modules. This generalize the essence of the Doodle Jump and optimize for the D10 nano platforms. And secondly, the display modules where the gaming is virtually brought to on the connected monitors. Thirdly, we integrate motion control modules to enhance the interactivities, and which allows in-games actions to be controlled by the real-world players' movement. Lastly, for the cloud services, we utilize the D10 nanoboard with the cloud services, facilitating the continuous global contest, and the others provides the secured scored storage, and which enables the real-time updates and accessibilities. And as you can see, the two pictures. The first one is the gaming screenshot, and the second one is the screenshot of the cloud services. And next slide, please. For the interactions, our primary objective here is to significantly enhance the interactivities. By using the IoT technology, we have the player scores and gaming process updates to the cloud services in real times. And also, we aim to provide the real-time feedback to the users. The IoT technologies enables the collections of the valuable gaming data from each players, which in turn informs us to how to optimize the game design for more engaged and personalized experience. And furthermore, the IoT technologies is about connections, and this is exactly what we bring to the Doodle Jump. By creating the connections among global players, we foster online communities that engage the interaction, contest, and the shared enjoyments of the gaming. We collect the important insights into the users' gaming habits and preference, and this has the significant marketing values as enables to more target effective outreach to our user space. And finally, most important is the Doodle Jump can service the dual role as both the fun games also as the learning tools. This is a unique platforms to teaching the concept such as programming, data science, and the IoT technology itself. And yeah.
Okay, so let us introduce to you some of our development process. The first is the gaming part. The game is basically developed on a Pygame framework. The Pygame framework will provide us with some basic attributes of gaming, such as the clock and timing, and the game configurations and settings like the frame rate and the size of the GUI, and also the events handler. It will call a handler function after we like press a button on the keyboard. And the last one is the graphic user interface. So the software will take in the output of the G sensor and interpret it into a data type that we desire, and we will compare that value to upper and lower thresholds to determine whether the doodler will move, whether the board is tilted to the right or to the left, and thus we can control the movement of the doodler on the screen.
Yeah, this part is about the jump platforms, or you can call it the levels. It will randomly generated with fixed offsets that allow players jump around and reach it. All the platform will be appended in the platform list, and there is some um, various types. Like we have normal levels, the level with the bounce, the breakable level, and the moving levels. Each of those special levels have a different chance to be generated. Once the level reaches the bottom of the windows, it will be removed from the platform list. This is an exciting part because we can have fun with our imagination. Like what I can think right now is we can have some invisible levels that the user can be seen on the screen, and but there's actually a platform. Once the player reaches to this platform, it will jumping around on the empty space, which I love this part mostly. Yeah.
And the next part of our development process is the sensing part. As I mentioned before, we plan to use the output of the G sensor on the board. At first, we plan to use the G sensor on the RFS daughter card, but it turned out that it is not compatible with the GUI output. We will talk more about this issue later. And anyway, we ended up using the G sensor on the D10 nano board. The test code of the G-Sensor on the D10 nano board was in C language, so we decided to use a Python subprocess to compile and run the C code and get the G-Sensor output. Originally, the output was in plain text, so we also need to decode the output as a data type that we desire, and in this case is the integer. And next part of our development process is the cloud service part. We use the Azure IoT Hub to receive to store the scores of the player. First, we need to use a connection string to connect our D10 board to the Azure IoT Hub, and then we can send the score to the cloud every time the game is over and the player presses the enter button on the keyboard. The D10 board will send a message to the Azure IoT Hub, and we can see the score of the player in the Azure IoT Explorer and under the telemetry. And that is how the cloud service works. And these are basically all the development process.
And for sure, we're gonna miss some obstacles during the project design. First of all is Pygame compile. We will try to install the Pygame directly into our project file, but it turns out the project can't find the Pygame module. And we searched on the internet, found that the Ubuntu operation system need to compile the Pygame before run it or before install it, and yeah, that's take a lot of time to fix this problem. The second one is the in relationship between the desktop and the overlay. The Data Nano have a function called overlays that enable us to apply RFS card on the Data Nano board. And with the RFS cards, we have much sensitive what's that? Oh, the G sensor,
yeah.
G sensor, yeah, on the card. And we were originally trying to use that, but when we enable the overlay, the desktop input from the HDMI cable will be disabled. And for sure, we can fix this problem by configure the FPGA code by the quarters, but that will take us much of time, and this project is time limit. So instead, we just use the G sensor on the board to design the project. Also, there is some like code issue and the environment issue, but rest of the problem are, let's say, much simpler compared with the top two problem I listed above. Yeah, now we're gonna demonstrate our game. Yeah.
Yeah, this is a short video. As you can see, there's a little square in the middle of the screen that is the doodler, and we have a number of levels. Like the forest green level is the normal level, and a small gray button on it is the bonus level, and the brown one is the breakable level. Okay, now the game is over, and when we press the enter button on keyboard, there is a message on the telemetry of the IoT Hub Explorer. The player score is shown on the screen. And now the game is restarted.
And you can play again.
There's a breakable level, bonus level, game over, and a new message on the IoT Hub Explorer. And so that is basically our final project, and thank you for watching.
Yeah, thanks.
Thank you. Thank you.